Today I'm going to be showing you the full diagnostic and repair process for a Frigidaire oven controller board. We're going to be doing minimal cuts and edits on this one, so it's going to be a long form. And we're going to go through the full diagnostics and repair process that we go through for all of these. So starting with testing, this is the unit. The customer did not send it in with the shell, so we only have the circuit boards. We're going to start by plugging it in, ground to ground, white to neutral, black to the L1 spade pin, and we're going to plug it in. All right, so that was one of the complaints from the customer, is a very dim display, and it's very hard to see. Let's turn off the lights. So we can see there obviously is a display, but it's very dim. And the other complaint they had, let me put in my fake sensors here, was that the 3 and 4. The relays would click, but the oven would not actually turn on. So we're going to go into continuity mode. When we have continuity, we get a beep. So let's see. So our baking element should not have a beep right now because it's not on. So let's press cancel and bake up. And let's listen out for it. Actually, our first click will be to broil. And then it'll click off and go to bake, or it should at least. And it is. So we got both continuity on the broil and on the bake element. Let's do clean, and the clean's going to be over here. Also continuity, so that's good. And finally convection. So that one we're going to go back to AC volts. We're going to go neutral to this one over here. And when it clicks, we should get 120, and that's what we get. Let's do actually back to continuity, and let's check the baking element, or baking and broil. Okay, here we go. Okay, is active. And I believe it goes back and forth between the broil and the bake. Okay, maybe we just start it over. Oop, wrong one. Convection. So when we do the convection. Okay, so the broil is on. Then it'll click off and then switch to bake. Okay, so I think our broil and bake are both activating. So it just clicked off. And then the bake. There we go. Okay, so actually it does look like we have every function is working as it should. The only issue that I'm currently seeing is just the dim display. So we'll go ahead and start with repairing that. And I guess we'll also take a closer look at some of the joints on the back side. Let's put that away. Okay, let's inspect. Everything looks good here. These joints over here are the baking and broil elements, or relays. Not seeing anything, no cracked joints. Huh, that is strange. So the customer was complaining of baking or broil element not working, but I'm not seeing any signs or reasons for that. Oh, you know what? You're not going to probably be able to see this because it's this very, very small cracked joints. No, you know what? It's so minor that I don't think that would actually be the cause of the fault. Well, what we'll do is we'll replace the relays anyways, just preemptively. But it doesn't look like they have failed, at least not from my perspective, not from our initial diagnostics and tests. So for the display, we have 2 support pins at the top, which are here and here. We'll start by desoldering those. And now this should lift right up. Yep. We have 3 more support pins over here. and over here. Okay, it looks like I got the left side, but the right side's not quite desoldered correctly. There we go, that's better. And now let's do the center pins. So I'm just using, right now, Chemtronics wick to desolder. We get this desolder wick on DigiKey, and I think with the volume we do, we get a small discount. So we usually buy 5 or 10 at a time, but they're fairly expensive. I think they're 35 bucks with the discount. All right, the display's out. So the remanufactured displays that we have, the brand new ones, they don't have those support pins on both sides, which means that we have to put a support pad, which is just a double-sided pad with adhesive on both sides. We'll put that more or less in the center. All right, and this part can be a little tedious. We need to line up all of the pins in the holes, and they're not always perfectly straight. So usually you got to play with it a little bit. Okay, here we go. And there we go, perfect. So I'm going to do a quick double check, make sure that all my pins are through, and they are. All right, now we can solder down the new display. And there we go. So before we proceed further, we're just going to go ahead and do a quick test. Make sure the display is nice and bright and that I didn't make any sort of mistakes on my install. Okay, that looks a lot brighter, a lot better. Oh no. You see how the F3, so they're supposed to say F3, there's a time missing. And I see why. I did make a mistake. It looks like this pin over here did not go in properly. So let's unplug. Yeah, I see it. So right here, we can see the pin actually didn't come through. So let's desolder the hole. And it was probably while I was adjusting. Okay, we're going to push that pin through. There we go. Now the pin, I see it. All right, one more test. Hey, that's better. Okay, all of our numbers are showing up. Obviously, we'll still get the F3 code. Since I don't have my resistors, my fake sensors plugged in, but everything else looks like it's going to be good. So display's done. Toss that out. Now, like I said, we're going to replace the relays anyways, even though I am not seeing any faults, but I am seeing the start of cracked joints. So technically, I think if we just reflowed, we would be okay. But I'd rather just replace to be sure. We do offer a 2-year or a 1-year warranty with the option for 2 years. And I just want to make sure that when we fix something, it's fixed right and it never comes back. So to be sure, we're going to replace them with brand new ones. Now for these relays, because they are on very large pads, they can be difficult to desolder. So I always add a little bit of solder first, and that's going to help me get better flow. And once I have good flow, then I come in with the desolder wick. Okay, I think I got it. So I'm just pushing them around, oops, with my tweezers to make sure they're loose. Actually, I can just yank that out. There we go. And it's typically a lot easier to desolder the joint when there isn't a component in the way. So I do like to, when I have a large pad and I need to transfer as much heat as possible, fold the desolder wick over the iron tip. That helps transfer, it has more contact, physical contact with the iron tip, and so it's easier for it to transfer that heat. There we go. And so the desolder wick will soak up more of the solder when you do that fold over technique. Alright, so these are brand new relays that we bought in bulk from DigiKey again. And if you are trying to do this yourself, we do have the kits available. I'll have links in the description, in the video description for these, if you're trying to do this repair yourself. So I was a little quick on the two smaller joints. We don't need to linger on those for as long because they are smaller joints. They're not on large pads like these guys right here. And these larger pads, I do tend to spend a couple extra seconds on the pads themselves just because they soak up a lot more heat, and in order to have a good solder bond we need a lot of heat transfer between both the legs of the relays and the pads on the PCB. Alright, so that is the replacement of the relays. Next, we're going to reflow the connector here, and I don't need to really desolder. We're just going to add a quick little bit of leaded solder just to help with good flow. None of these look cracked or damaged, but they can crack or damage, so that's why we like to reflow them preemptively so that we don't have any issues down the line. Right now I'm doing a relay. This is the clean relay. And then over on this side, let's see right here, we have the convection relay. We'll also want to touch up the transformer. That's these pins over here. Some of these are no connects that I'm touching up. I don't need to, but I do it anyways. All right, next we have our spade pins. So these we do sometimes see with cracked joints. So again, there's no immediate fault. This is a preemptive repair, if you will. It's kind of one of the things we like to advertise, that we don't just fix the immediate fault, we also preemptively tackle strengthen, I guess upgrade the board by reflowing everything that is prone to having cracked joints, so that even though there isn't a cracked joint today, by reflowing it, we're ensuring that there won't be one down the line, at least not for many, many more years. And our last one. There we go. So the very last thing that we'll do is replace these 4 capacitors. So same thing. They are not bad right now, but if they are not replaced, we have seen, especially this smaller one down here. We'll do it first. It's this guy over here. Location ID C9, 100 microfarads, 50 volts. This one will tend to start leaking electrolytic fluid, which will then start to corrode and damage the PCB. When replacing these capacitors, you do have to be very careful because the traces are very fragile and they can be difficult to replace. So I start with desoldering, and then I wiggle the capacitor on the back, and I can see here both of the legs are wiggling, so that means I am safe to use my pliers and wiggle it out. So I have a black bar down here. I have a negative sign on my capacitor, so that's how I know the orientation. Push that bad boy all the way through. Solder that in, and we'll cut off the leads. Then we'll move on to the next one that's right next to it. Same thing. So I desolder from the top, and then I kind of grab a little bit of an angle and try to desolder from the side, and the reason is because the legs are bent down. So can we wiggle it? Yep, it's wiggling. And so sometimes there is going to be solder trapped between the PCB and the leg, and desoldering from the top doesn't always work. So that's why I try to do a side angle on it. Okay, so that first one was 100 microfarads, 50 volts. These next 2 small ones we're doing are 470 microfarads, 16 volts. Same thing. And you know what? I'm gonna check something. Okay, we're gonna go to continuity mode, so checking for beeps. I wanna make sure I have continuity. Okay, and I do. So it's kind of hard to tell on the camera, but it looks like I might have damaged the pad a little bit, but because we have continuity, that confirms we're okay. I just want to be careful with these. They're very fragile, like I said earlier. All right, so our next one's over here. Come on. Okay, can I wiggle? Yep. See, it probably just, yep. All right, it was loose enough I knew I could just pull it out. So 470 microfarads, 16 volts again. Same thing, we have a black bar, negative sign on my cap. That's how I know the orientation. And then our last one is this big guy over here. So this one I've always been kind of hesitant to replace, and the reason for is it never fails. I have never seen it fail in the hundreds and hundreds of these that we've done. But we do include it in the kit. We know other companies that do these services also replace it. So I don't know if they have seen this capacitor fail, but this one is the 16 volts, 3300 microfarads. So just as a precaution, we go ahead and replace it as well. But I don't actually think it's necessary. Thing is, if we're going to go through the trouble of fully refurbishing this unit, might as well do it right. So if we think there's a chance this guy might fail, we'll replace it. Okay, I think that completes our repair. We did the relays, we did the reflow, we did the display, the capacitors. At this point, the last thing left to do is a final test. So actually, there is one more thing that we typically do, but the customer did not send the shell, and it would be to clean the shell. So the shell itself sometimes will get, I think, smoke. I'm assuming it's not dust. I assume it's smoke just from the oven, and that will cloud the display. So we always clean that with soap and water. And let's see, plug it in. We still have power, that's good. Let's see, put our thermal probe, fake thermal probe, in our fake door lock. There we go. Okay. Let's see. Perfect. Final continuity test. We get a beep when we have a short. See, bake, and up. Oh, it'll go broil first, that's right. So just by default, whenever you bake something, it kind of switches back and forth between the broil and the bake elements so that it can heat it up from the top and the bottom. And when we do broil, it will only heat up the top heating element, the broil element, and not switch back and forth. Okay, we're good there. We'll do the clean feature. That's this relay down here. Cool. And finally, the convection. So let's start by checking the broil and bake element first again while we're in the continuity mode. So I just heard the actual relay for the fan clicked first, then the broil element, then it should click off, and then it'll switch to the bake. There we go. And then to check the convection, we'll go to neutral, and we should get 120, and we do. And let's press cancel, and I heard it unclick, so we no longer get the 120, so we're all set. All right, that confirms we have a fully refurbished Frigidaire oven controller board. If you liked this new format for the content with minimal editing and cuts, let me know in the comments down below. If you have a Frigidaire controller board that you would like to send in for us to fix, we do offer the flat rate services. I'll also have links for that in the description down below. Otherwise, if you found the content helpful or useful, leave us a like, subscribe for more, and thank you for watching.